In the second video about the comparative advantages of case study methods, I'm going to be talking about some challenges and critiques of case study methods and which ones have some validity and which ones don't. So first thing to note is that there are many different purposes and goals for research. The reason that Alex, George, and I called our book Case Studies in Theory Development is to reflect these many different kinds of theory development goals that we can have in research. Other approaches to research tend to focus on only one aspect or another. The King, Cohen, and Verba book, for example, tends to focus a lot on theory testing and not much on generating new ideas for theories. So theory testing is an important goal for research. Often you'll hear the critique that, well, case studies don't really test theories, they mostly generate them. I think that's a misplaced critique. You can test theories in cases. You can ask whether a case fits a theory. And if it's a case that should fit the theory, but it doesn't, then you could question the theory. And so we use process tracing or within case analysis to see whether the hypothesized process actually took place in the case. We'll talk a lot more about process tracing in another session. So we also try to use cases to come up with new ideas and new theories and new understandings of mechanisms. Often we'll pick a deviant case or an outlier case, a case that does not fit our prediction or our expectation or some previous statistical or other analysis, and then we'll study that case to see if we can help identify maybe some variables that we left out or some new ideas about causal relationships. We might use cases to probe the scope conditions of a claim or a theory to see, what's the least likely case where the theory still works or the most likely one where it doesn't, and to get a sense of, under what conditions do these mechanisms operate. We also think that just explaining individual cases theoretically, why was there an outcome in this particular case, that's a valuable contribution to research. Even if it doesn't generalize, we've still added to our stock of knowledge. So that's a purpose that we value, and it's one that statistical studies can't get at, and so they tend not to value that purpose. Case study researchers think that's an important goal all by itself. Okay, so one advantage of case studies is that they can get at certain kinds of complexity in better or at least in different ways from other kinds of research methods. And I want to single out 3 different kinds of complexity. In particular, we'll talk some more about these when we talk about typological theorizing. So one form of complexity is what we call path dependence. Path dependence is when the order in which things happen makes a difference to the ultimate outcome. The classic example of path dependence comes from economics, and it's the example of the layout of the keyboard on your computer, or it used to be on typewriters. Initially, when typewriters were made, they were mechanical. There were mechanical arms with keys, and if you typed too quickly, then the keys would jam together and get stuck, and you'd have to stop and untangle the keys. So because of that, the keyboard, the position of the keys on the keyboard, was laid out in an intentionally awkward way to slow down the typing so you wouldn't get these jamming arms of the keys in the typewriter. Well, now it's many decades later, and we don't even have, the typewriters haven't been made for, I think, about 30 years. It's all computers now, and there's no need for a QWERTY keyboard where your home row is QWERTY in English. And in fact, there's an alternative way of making keyboards. It's called Dvorak, and that's a much better way of making keyboards. It fits so that the most common letters are in the home row. You can learn it more quickly. You can type it more quickly. It results in fewer injuries to your hands and wrists. And yet, still, most keyboards are laid out in the QWERTY fashion because there's a legacy that people were taught that way, and typewriting classes were that way, and everybody learned that way. And so older people didn't want to invest in learning a new keyboard, even if it was more efficient and faster. So even though young people could start out with the Dvorak system and benefit greatly from it, most don't. And so economists use this as an example of path dependency, where you ended up with an inefficient outcome that still perpetuates because of either sunk costs or institutional externalities or some other factor. Another example, a political science example, would be what's called the resource curse. There are various versions of the resource curse. Some have to do with economics. This one has to do with politics. And this is the idea that if a country discovers oil in particular or some other cheap natural resource and it has not already become democratic, then it's less likely to become democratic after discovering a cheap natural resource, or what we might call a lootable resource. And the reason for that is once it discovers that resource, it uses that for government revenue. It doesn't have to give people the right to vote in exchange for people being willing to give up tax revenue to the state. And it spreads around the revenue of the resource to other elites to keep the government in power. On the other hand, if you become a democracy first, and then you discover some natural resource that generates rents or high profits, then you might stay a democracy. So think, for example, Norway, which was already a well-established democracy by the time it started to develop offshore oil reserves, and it has stayed a democracy, whereas other countries that got to oil first have not become democracies, right? So that's a simple path dependency. Now, it's not impossible, I would say, to study path dependency using statistics or other methods, but it's very difficult because you would have to have a lot of cases to study it. And typically, you don't see path dependency used as a theory in statistical research. I would say almost all of the path dependency studies I've seen use case studies. It's not a necessary connection, but de facto, that's the way that has happened. A second kind of complexity that I touched on in the earlier video, equifinality, different paths to the same outcome. And those paths may have little or nothing in common, or they may have a fair amount in common. We actually don't have yet a standard vocabulary for this. We should, or maybe I should just develop it myself. But imagine there may be 100 different paths to an outcome, and maybe 90 of those have a particular variable in them, and so you would say that variable is almost necessary for that outcome. Almost all the paths to the outcome have that variable. On the other hand, maybe the 10 paths that don't have that variable, maybe that's 90% of the cases. So then that variable isn't. It's necessary to most of the paths, but it's not necessary in most of the outcomes, right? So we can have a lot of overlap or very little overlap of the different paths where they either have a lot of variables in common or almost none. And the how common the path is a different question from on how many paths does this variable matter to the causal outcome. So a variable may be in lots of paths, but not many instances of the phenomena, or only a few paths, but most of the instances of the phenomena. So there can be different kinds or degrees of equifinality. And then the third kind of complexity I touched on earlier as well, this is high order interaction effects, where the effect of one variable depends on everything else that's going on. The effect of having a free media depends on whether a society is democratic in other respects or authoritarian in other respects. It depends on whether that free media is aligned with political parties or separate from political parties. There's lots of other things that affect the nature and the interaction of the free media. It depends on whether there's a lot of social media or not, as well as newspapers and television that are independent of the state, right? So how free media affects polarization depends on a lot of different things, right? Okay, so case study researchers focus a lot on these kinds of complexity, and we address them in our research. They tend to get neglected in statistical research. Concepts and measures and variables. So case studies try to have very good conceptual definitions of variables because we can measure them in depth in particular cases. And David Collier has called this, measurement, close-up measurement, or measurement that gets very close to the action in the case. On the other hand, if we have measurement error in a case study, that could be a big problem, because we're only studying a few cases, and if we measured the variables wrongly, we could be making completely inaccurate conclusions. So I would say measurement error could be a bigger problem if it happens in case studies, but I would say it's less likely to happen in case studies because we learn a lot about our cases and we measure them closely. We're not trying to do sort of shallow measures across many, many cases, as statistical researchers sometimes have to do when they're doing big data sets with hundreds or even thousands of cases. They may have lots of different researchers trying to measure them, and then they have to worry about inter-coder reliability. Would every coder, everybody who's coding or measuring a case, come up with the same measure of the case, and so on and so forth. So I would say we're less likely to introduce measurement error in case studies, but if we do introduce it into our research, then it's a big problem for our research. Okay, one of the most misunderstood aspects of case studies is the question of generalization. Now, I've said earlier that case study researchers don't automatically assume that case study results will generalize. We tend to be careful about generalization. We tend to be skeptical about sweeping generalizations to big populations, but that doesn't mean that we cannot generalize from cases. Now, we don't necessarily select cases with the goal of generalization. We may or may not have that goal as part of our research, or even if it's not part of our research agenda, it may emerge as a result of the research, or even if we're trying to generalize, we may decide that we're not able to do so. So partly whether generalization happens or not, it depends on the results we find of the case studies. So we often don't know until we've done the case and figured out what we think is the proper explanation, and then we can start to make an assessment based on the nature of that explanation about whether it generalizes. Do the conditions we think are necessary for those mechanisms to work, are those conditions very common or are they very rare, right? So let me take two examples here. First, let's take the example of Darwin. Charles Darwin went off to the Galapagos Islands, some small islands off of South America, and his father was very disappointed because he felt like, what could he possibly learn by going to these islands and studying, a few bird species? And Darwin, in studying those bird species, he came up with a theory of evolution, and the scope conditions of that theory are not just a few bird species. The scope conditions for that theory are all living things. Plants, animals, bacteria, everything. Those are the scope conditions for the theory of evolution. He happened to discover it through studying a few birds. He could have discovered it through many other species, but that's the way he did it. And so once he understood the nature of that theory, the scope conditions were obvious. It should apply to all living things, right? Let's take another example. Let's imagine that you have lots of data about how individuals vote in an election. And there's a voter that by every theory and every measure you can think of, you expect them to vote for candidate A, but you know they voted for candidate B, okay, based on their party affiliation, their gender, their age, their education, their wealth, their ideology. Everything says that they should vote for candidate A, but you happen to know that they voted for candidate B. And so let's say that you ask them, why did you vote for candidate B? And they say, well, B is my sister-in-law. Well, now you have a very convincing explanation, but you also immediately understand that that explanation probably does not generalize much unless you're talking about a small community where there's lots of intermarriage. Now, I used to use this as a hypothetical example, but a few years ago, the governor of Illinois here in the United States was impeached for corruption, and he was impeached by the legislature in Illinois. And there was one person who voted not to impeach the governor, and that was the governor's sister-in-law. Okay, so these cases do happen. It's just by their very nature, we immediately understand they don't generalize very much, or they happen only in very particular conditions, right? So once we have an understanding, or we think we have an understanding of of the explanation of a case, the nature of that explanation may tell us something about whether and where it generalizes or not. We can start to get some ideas and clues about the scope conditions under which those mechanisms operate. And it's not all or nothing. In the case of the voter, we do know that in some societies that when there's ethnic voting and last names are taken as a marker of ethnicity, that there's this kind of affiliation that's not ideological or anything else that affects voting behavior, much as closer family relations, in my example of the sister-in-law, might affect voting behavior, right? So we may get some ideas about whether and how to generalize just by the nature of the explanation of the case. And when they do generalize, they often generalize to some specific type or subtype, some combination of conditions or variables, rather than to an entire population, right? A lot of times in medical research, you may get a better understanding of a disease and then say, okay, well, this is going to apply, to this group of people who are, older and maybe overweight and smoke cigarettes or whatever else, and not necessarily to everybody in the population. So we may generalize to some type of cases. Okay. Another critique of case studies is that they may suffer from indeterminacy. You may have two alternative explanations of a case. They may be mutually exclusive, and you may not be able to say, based on the evidence, that which explanation you find more convincing. And that can be a problem. That can happen. I would say this is a manifestation of a more general problem in the philosophy of science. This is called the problem of the underdetermination problem, that theories are underdetermined by evidence. Evidence doesn't always exclusively point us to one explanation or one theory or another. This is when I talked about philosophy of science earlier and I talked about the Quine-Duhame problem. This is a problem of underdetermination, that we don't know if a theory doesn't fit, should we get rid of the theory, or is it maybe that there was a mistake or error in the measurement or something else? So this is part of the underdetermination problem. Now, the problem of underdetermination can arise whether you're using statistics or case study methods or anything else. It's a general philosophical problem. But the way that it arises, the way that it comes up, may be different in case studies than from other kinds of studies. So here, there's another big misunderstanding about case studies that comes from looking at case studies through a statistical mindset. And this is called the problem of degrees of freedom. Now, we don't see a degrees of freedom critique of case studies as much as we used to, because now more and more people understand that's not the appropriate way to think about case studies. But let me explain what the degrees of freedom problem is, why it applies in statistics, why it does not apply in case studies. In statistics, the degrees of freedom refers to the number of parameters you're trying to estimate minus the number of cases that you're studying minus 1. Just mathematically, that's what it is. And so in statistics, you need a positive degrees of freedom to even do statistics at all. You need way more cases. You need a larger n, number of cases in your population. Then you have number of parameters or variables that you're trying to estimate, right? If you have more parameters than you have cases, then you cannot do statistics. It's like trying to divide by 0. Simply mathematically, you cannot do it. And indeed, you want very high degrees of freedom. The higher, the better. So you want hundreds or even thousands of cases and a relatively small number of variables. And then you can have powerful statistical claims. Now, people trained in statistics sometimes take that way of thinking and they'll apply it to case studies. And they will say, oh, well, your case study has 4 explanations and you're only studying 3 cases. And so you have negative degrees of freedom, and so you can't do your research. Well, that's a totally inappropriate way to think about case studies. And in fact, Don Campbell, who's a well-known statistical methodologist of some years back, used to think that way, and then he wrote an article called Degrees of Freedom in the Case Study, and he explained why he now understood that that was an inappropriate critique of case studies. Well, why is that inappropriate critique of case studies? It's because case studies use a Bayesian logic and not a frequentist logic. In Bayesian logic, we make guesses on the strength of different explanations based on evidence, but it's not based on the number of pieces of evidence or the number of cases or the number of alternative explanations or theories. It's based on the strength of evidence or the weight of evidence, right? So we could have one piece of very powerful evidence that knocks out all of the alternative explanations but one. Imagine if you're, a criminal investigator and you may have a very strong incriminating piece of evidence, let's say a videotape of the murder that shows the face of the murderer, and you could say that is the person who committed this crime. It's not anybody else, right? And that's true whether there's, 10 other suspects or 100 other suspects or 1,000. It's the strength of the evidence, not the number of suspects or the number of cases that matters, right? Conversely, you could have lots of pieces of evidence, 100, 1,000, whatever, and if they're all weak pieces of evidence, they don't strongly discriminate between alternative explanations, then you've got a problem of indeterminacy. So if you're the prosecuting attorney and the evidence is equally consistent for two different suspects, only one of them could have committed the murder, well, you still don't know which one. You can't convict one of them because even though you have lots of pieces of evidence, none of those pieces of evidence, or even all of them together, don't strongly point you to one suspect or the other. So in case studies, it's not the number of cases or the number of variables or the number of alternative explanations. It's the strength of the evidence that matters as to whether you have an indeterminate research design or an inability to strongly discriminate between alternative explanations. It is not a degrees of freedom problem. So if you ever get somebody who raises a degrees of freedom critique of your case study research design, then you will have to explain to them why that's the wrong way to think about this. Okay, another challenge, or really could be an opportunity, is a lack of independence of cases. Now this can arise also in statistical research or case study research. In statistical research, if cases are not independent of each other, in other words, if what happens in one case affects what happens in another case, so for example, one case happens first and then actors look at that case and they change their behavior, well, if you're treating cases statistically as if they were independent when actually they're dependent, one case is affecting the outcomes of the others, then if you make that mistake, you're essentially inflating the sample size. You're acting like you have a lot of different independent cases when in fact they're dependent. In fact, if one is causing all of the others, you only have one case really rather than 100 or 1,000 or whatever else, right? So in statistics, an unrecognized lack of independence of cases overstates the sample size, right? In qualitative research, we're not dependent on sample size in that way, so it doesn't come up in that way. But if we neglected dependence between cases, if we overlook the fact that these cases, the actors were learning from these earlier ones and changing their behavior, then we will make a mistake in interpretation. But I would say we're unlikely to make that kind of mistake because often we're paying attention to learning, to diffusion, to imitation or emulation. So for example, in studies of the Arab Spring, the series of revolutions throughout the Middle East in 2011, it was very clear that actors in the later cases, including both governments and revolutionaries, were trying to draw lessons from earlier cases and therefore adapting or changing their behavior. So if you're really studying cases like that closely, it's unlikely that you're going to neglect the fact that these actors are paying close attention to what's going on in earlier cases. So really, this is an opportunity to study learning, emulation, diffusion. And if you overlook that, yes, you would have a problem for your research design if you ignored those sorts of things, right? Okay, some additional issues. Some critics act as if it's not allowed to sort of move back and forth between your theories and your empirical observations and to change and adapt your theories in response to the evidence that you're encountering. Now, in statistics, there's a good reason for that, and that is statistically, if we adopt an arbitrary standard that a 5% significance level, in other words, if it was on average, only 5% likely to have a certain correlation if the data were just randomly organized, then we would say it's unlikely that I have this correlation for random reasons, and therefore I'm able to publish in a journal. Well, if I did 20 different model specifications and just kept changing the model and changing the model 20 different times, well, on average, one of those 20 models is going to hit the 5% level, right? And 5% is 1/20th of 100%, right? So on average, if I did 20 different models, one of them just randomly will look like it's statistically significant, even though it's actually just random. So there's a good reason that we don't do what's called curve fitting or p-hacking. P is the significance level in statistical study. P-hacking is trying lots of different specifications of your model until you hit that magical, 5% significance level, and then you get to publish, right? So there's a good reason you have to be careful about moving back and forth between theories and evidence and statistical studies. In case studies, the logic is different. It's a Bayesian logic, and so therefore we're going on how likely or unlikely is the evidence depending on the nature of the theory or explanation or the alternative explanations. And therefore, it's quite possible to go to evidence, come up with a new explanation, and still make a claim about how likely is that under this explanation I've just come up with versus how likely is that evidence under the alternative explanations. We'll look into this a lot more when we talk about Bayesianism, but in the slide here I've given an article which sort of articulates this perspective. Second, selection bias, selection effects can be a big problem in case study research if we don't recognize them. We should be alert to the dangers of selection bias or aware that there may be some earlier behavioral choices that result in the populations that we see. So let me give you an example of a selection effect. There are a lot of studies of whether economic sanctions work in the sense of succeeding in getting a state to change its behavior. Well, one big problem here is selection effects. So if a state knows that it's likely to get economic sanctions if it does an invasion across a border, for example, then it's already weighed in the costs of those possible sanctions before it even makes the choice to invade. So if it's weighed those costs and chose to invade anyway, then it's not likely to change its behavior unless the sanctions prove to be much more expensive than the state anticipated, right? So already the states that have chosen to risk sanctions are the ones that are unlikely to change their behavior once sanctions are applied. Whereas there may be a lot of states who look at the possible costs of sanctions and then choose not to invade in the first place. And so sanctions may work at deterring many states, at preventing them from invading across their neighbors' borders. But once a state has made that decision to invade, knowing they're probably going to get sanctions, and sanctions probably will not work in the sense of reversing their behavior, right? So we should pay attention to selection effects. This comes up a lot in, crises and wars. Do states just not have crises with each other, or do they have lots of crises that then some of those result in wars? We want to pay attention to the whole process through which states choose to have crises and which from those crises they choose either to have wars or not. We want to be aware of those selection processes. So if we were ignorant of those and we did our case studies, then we would be missing a lot of the explanatory action. I would say we're not likely to miss that because if we're studying the cases closely, we're probably paying attention to those issues, right? As we'll see when we talk about research design, the way we think about selection effects and selection bias is different in case studies than the way we might think about that in statistical studies. So we'll come back to this issue. Case comparisons have their uses. There are different kinds of comparisons. Most similar, least similar. We'll talk about that when we talk about research design. But I would say that single case studies also have value. Sometimes critics have said you shouldn't do a single case study or what might be called a no variance design. There's no variance on the dependent variable. First of all, there's a lot of confusion about whether a case is a single case or it's multiple cases, even confusion among case study researchers sometimes. Just because I'm studying one country doesn't mean I only have one case. I could be studying it over time, so I have a before and after, or I could be studying different administrative districts in one country, cities, federal states within the overall country. And so I may actually have many, or it could be even studying organizations or individuals, so I may actually have many cases rather than one case. But even if I only have one case, there are values to studying one case. It could be a deviant or outlier case, and I might study it to find some new theoretical ideas. It could be a case that disproves a claim of necessity or sufficiency. So if somebody says, this is necessary for this outcome, and I show a case where it didn't happen and we still had the outcome, I've disproved the claim. Or if somebody says, well, this is sufficient for that outcome, I could show a case where that happened, but the outcome did not happen, I've disproved a claim of sufficiency. So single case studies have their uses, although often we'll want to do multiple case studies or compare cases. Case studies do not give estimates of the average relationship or the average effect of variables across a population. That's what regression analysis tries to do. It's optimized for that. Case study researchers, our methods are not optimized for that. We may make claims about causation, but it's usually in a very narrow sense about a case or type of cases and not about whole populations, as I mentioned earlier. Case study researchers do not necessarily assume deterministic causal relations. They might assume probabilistic ones. Neither do statistical researchers assume probabilistic relations. Some of them might think that many relationships are more deterministic. In fact, the King, Cohen, and Verba just asserts in a footnote without any empirical evidence that most statistical researchers actually have deterministic views of causation. I think that would be an interesting thing to study or survey on. I don't know of any surveys of that, but I would say that we should not assume that researchers in either community are monolithic in their views on either determinism or probabilism. Finally, I would say case studies can help us get at issues of endogeneity and spuriousness. Now, endogeneity is a general term for when you have variables left out of your model that may affect the causal relationships. I want to focus in particular about one form of endogeneity, which is where there's reciprocal causation or feedback effects. So take an example here. Do arms races cause war? Or is it because actors see a war is coming that they then engage in an arms race? Or maybe sometimes it's the first one, arms races lead to the war, and sometimes it's the second one, the war leads to the arms race. Now, this kind of reciprocal causation is a very common challenge in all kinds of research, and it comes up in statistical research a lot because even if you show a correlation, the things move together, and even if it's a causal correlation, it doesn't necessarily tell you if A causes B or B causes A. Whereas if we look at the sequence of events in case studies and the order in which things happen and what knowledge different actors had at different points in time, then we can start to unravel the direction of causation in that case, right? Spuriousness is where there are two variables that may be moving and correlated, but really the correlation is not A causing B or B causing A. It's some third variable that's moving both of those variables up or down together. And so case studies, again, might at least uncover that. We could still miss it. There could be a third variable we've left out. We don't recognize it even when we do the case study. But because we're closely studying the case, I would say we're more likely to uncover variables that may have been left out of other kinds of research. In statistical research, once you specify the theories and the variables, you're not really using the cases to identify new theories and variables. You're using them just to measure the values of the variables in those cases. If in the process of doing that, you actually realized, that maybe I've left something out, well, then you could still add it. But typically that's not your focus. Your focus is just on measuring the variables in the cases. Okay, so those are some observations on the comparative advantages and some of the challenges of case studies. If you're taking a class with me, and you're studying either by yourself or in a group, let me ask you to take a few minutes and write down on the Google Doc I've provided either just general questions you have about this presentation, but also try to think of examples either in your own research project or in your field, examples of research that you know about, or maybe even in other sciences or other fields, examples of some of these phenomena that we could talk about in class. Path dependency, equifinality, high order interaction effects, findings that you think did generalize or could generalize, or findings that you think don't generalize, selection processes or selection effects, and then endogeneity, especially reciprocal causation. So try to think of some examples of each of those and write them into the Google Doc. Okay, thanks.